Hello, good morning everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Chemical Equilibrium from Chemistry, and in this session we are going to learn about the factors affecting the equilibrium. Okay, already in the previous class or in the previous lecture we have discussed two factors which are influencing the position of the equilibrium. What are those? Concentration of the reactants and products, that is one factor which determine the equilibrium, and another is pressure we have discussed. In this lecture we are going to discuss the other factors which are influencing the equilibrium position. Okay, so let's start the session. See here, the next factor which influence the equilibrium position is temperature. What is the effect of temperature? What is the effect of temperature? So let us see, this reaction is given here. What is that? 2NO2 gives rise to N2O4. What is this NO2? NO2 is nitrogen dioxide. Dinitrogen tetroxide is N2O4. What is this? Dinitrogen tetroxide. So what is this nitrogen dioxide? So if nitrogen dioxide, what is the color of nitrogen dioxide? What you are finding? Brown color. And what is the color of N2O4? It is colorless. It is colorless, right? So what is given here? This forward reaction is exothermic. What you are given? 2NO2 gas. Okay, it is in equilibrium with N2O4 gas, where here delta H is given as minus 57.2 kilojoule per mole. What does this represents? Minus forward reaction is exothermic. What is that? Forward reaction is exothermic. If forward reaction is exothermic, what will be backward reaction? No doubt about it, it will be endothermic. So what will be that? Backward reaction is what? Endothermic. What is the meaning of exothermic reaction? What is the meaning of endothermic reaction? In the previous lecture we have discussed. Okay, exothermic reaction means the reaction in which it proceeds by releasing heat. Endothermic reaction means the reaction which proceeds by absorbing heat. That is net heat energy. Okay. So in simple language, what we can discuss, exothermic reaction means reaction in which heat is released. Endothermic reaction means the reaction in which heat is absorbed. Simple language. Simply understand. So when delta H is minus, what do you understand? It is exothermic. So here writing delta H means that it forward reaction. For forward reaction they are mentioning. For backward reaction automatically it will be endothermic. If forward reaction is endothermic, then backward reaction will be exothermic. So you have to remember that if forward reaction is exothermic, the backward reaction will be endothermic. If forward reaction is endothermic, then the backward reaction will be exothermic. That's it. Okay. So what does this exothermic reaction says? Exothermic reaction says that reaction happens by releasing heat energy or by releasing energy. Okay, releasing heat, the reaction happens. So it doesn't want heat. It doesn't want heat. Okay, when does this happen? In general condition also, when does this happen? It happens at low temperature. At a low temperature. So now let us see. Now this is equilibrium. What is that? Now NO2 and N2O are N2O4 are in equilibrium. So the color will be brownish, not more intensity of brown color. It will be medium intensity of brown color. Okay. Now you see, when I when this mixture, see, when this equilibrium mixture is kept, when I am keeping it in, what is that? What is this contain? Both NO2 as well as N2O4. It is equilibrium mixture. So now when I am keeping it in a container which contains some hot water. What is that? Hot water. Very hot water, high temperature. That means hot water means high temperature, more temperature. That means you are giving heat energy into the container. See, heat Q is flowing into the container. So when Q amount of heat energy is flowing into the container, you are finding that see here the color, brown color, intensity of brown color increases. What is happening? Intensity of brown color increases. That means it will become thick brown. Why it is becoming thick brown color? Because the net rate of the reaction is backward. The net rate of the reaction is what? Backward. Because backward reaction is what reaction? Endothermic reaction. Endothermic reaction requires heat energy. And you are supplying heat energy to it. When you are supplying heat energy, automatically what reaction occurs? Endothermic reaction favors. Initially it is in equilibrium. Now when you are supplying some, when you are changing temperature, equilibrium is disturbed. What happened? Equilibrium is disturbed. And the nature of the reversible reaction is to attain equilibrium. So when you are changing the conditions determining the equilibrium, then the reversible reaction or this reaction will behave in such a way to make the change zero. So simple language, what you need to understand is when you are giving heat energy, when you are increasing temperature, giving heat energy, that heat energy is used to increase the temperature of that substance. So when you are supplying heat, temperature increases. When the temperature increases, for whom temperature is required? For endothermic reaction, temperature is required. So the reaction, net reaction moves the endothermic reaction side. What is endothermic reaction side? Backward reaction. Here in this backward reaction is endothermic side. So automatically it moves backward. That means equilibrium shifts to left. So that is what here it is mentioned. You see, at high temperature, the brown color intensifies because backward reaction is favored. Why backward reaction? Because backward reaction is endothermic. Endothermic requires heat. You are supplying heat. That means temperature increased. So simple language, when temperature is increased, backward reaction occurs. When temperature is decreased, forward reaction occurs. Understood? These two things you need to remember. That's it. So for example, now this reaction mixture, this equilibrium mixture, what is this? This equilibrium mixture I am keeping in ice, for example. What I am doing? I am keeping this equilibrium mixture which is containing NO2 and N2O4. I am keeping it in ice. What is this? This is all ice. That means when you are keeping in ice, that means you are decreasing temperature. What you are doing? Decreasing temperature. When you are decreasing temperature, not only what we have done, what we have seen, at low temperature, the intensity of brown color decreases. That means the actually it will be light brown color. But when you are keeping it in ice, slowly you will find the color of the brown decreases. You will find the fading of a brown color. If brown color fades, why it is fading? Because the reaction is moving in forward direction. In which direction the reaction is moving? The reaction is the net rate of the reaction is forward direction, because at low temperature what reaction occurs? Exothermic reaction occurs. What is exothermic reaction? Forward reaction is exothermic or backward reaction is exothermic? Forward reaction is exothermic. So forward reaction takes place. When forward reaction takes place, NO2 is converting into N2O4. What is the color of N2O4? The color of N2O4 is colorless. That is the reason why slowly the brown color goes on fading, because of more formation of N2O4. Because of the more formation of N2O4, what is happening? The brown color is slowly decreasing. You will find fading of brown color. So from this experiment, we can understand that at low temperature, exothermic reaction occurs. At high temperature, endothermic reaction occurs. That means at low temperature, equilibrium is shifted to exothermic reaction side, and at high temperature, equilibrium is shifted to endothermic reaction side. These things you need to remember. Okay. Next, let us see another example. So what is that? So one COH2O taken 6. This is what colored? Pink color. And Cl minus is colorless. And COCl4 product is in blue color. What is that? Reactant pink color, product blue color. And what is this reaction? Delta H, what you are finding? It is positive. Positive means what reaction? Endothermic. What is this reaction? Endothermic. Endothermic is forward reaction is endothermic. Forward reaction is endothermic. If forward reaction is endothermic, what happens to backward reaction? Automatically backward reaction will be exothermic. Okay. If forward reaction is endothermic, what will be backward reaction? Backward reaction will be what? Exothermic. Exothermic. So simply understanding, already we have discussed that now this is in equilibrium. This reaction is in equilibrium. As this reaction is in equilibrium, now you are changing the temperature of this reaction. When you are changing the temperature, the equilibrium is disturbed. And what does this reaction do? It will try to attain, or it will try to regain the equilibrium. To attain again equilibrium position, what it has to do, it will do. So that the given change is made zero. Okay. What change did you bring? You have brought a change in temperature. So as you have brought a change in temperature, it will behave in such a way to counteract the change, to make the change zero. So simply understanding, now if you decrease the temperature, exothermic reaction favors. That means equilibrium shifts to exothermic. What is exothermic reaction? Here exothermic reaction is backward reaction. So decrease in temperature. What happens? Exothermic. Exothermic reaction. The rate of net rate of exothermic reaction favors. That means here exothermic reaction is which reaction? Backward reaction. So when products are converted into reactant, what color intensifies? pink color appears. Pink color appears. Why is pink color is appearing? What has happened? Product is converting into reactant. That is, more reactant is produced. More the reactant, more pink color. See, when this reaction mixture is cooled in freezing mixture, so you are freezing it. The color of the mixture turns pink. Why it is turning into pink? Because of more formation of reactant. Product is converted into reactant. See, at room temperature, the above equilibrium mixture is blue due to the formation of the product. That means when the temperature is more, automatically forward reaction is what reaction? Endothermic reaction. So the net rate of forward reaction happens so that the equilibrium is moving in right. So the equilibrium shifts to right when you increase the temperature. The equilibrium shifts to left if you decrease the temperature, because if you decrease the temperature, exothermic reaction favors, backward reaction is exothermic. When you increase the temperature, endothermic reaction favors, so forward reaction is endothermic. Okay, so that is about the effect of temperature on the equilibrium position, right? Next, let us addition of inert gas. Next one is what? Addition of inert gas. Effect of addition of inert gases. We know inert gases. Helium, neon, argon, krypton, xenon, okay, radon. But mostly we will find helium, neon, argon, up to krypton in the so far examples given in different competitive examinations. So inert gas mean that this gas does not react with the reactants or products. Inert gas mean the gases that do not react with reactants, either reactants or products. They don't react. What happens? They don't react. So now addition of inert gases at constant volume. What does that mean? Constant volume means, let us take a container. Okay, let us take a container. So are taking this container and you are fixing it by using some you are fixing this piston. So piston does not move up and down. It is fixed by using some screw. What did we do? We have screwed it so that the piston does not move and up and down. So when it does not move up and down, then what happens? Volume is equal to constant. Volume is equal to constant. Piston does not move up and down. Now the total pressure of the system is increased, but the partial pressure of each reactant and products remain the same. Hence, no effect on the state of equilibrium. So now there is an equilibrium. A gives rise to B. What you are doing, keeping this piston non-movable, you are adding some inert gas. What you are doing? Inert gas is added. When you add some gas here, pressure increases because some more gas is added. No, more molecules are there. Right? But is there any change in the concentration? After adding inert gas, will there be any change in the concentration? See, for the reaction A gives rise to B, what will you write? For example, let me take 2A gives rise to 3B. 2A gives rise to 3B. So what do you write Kc? Kc is equal to B concentration power 3 by A concentration power 2, whatever it is. Okay. Now, it is in equilibrium. What is that? It is in equilibrium. Now, what you are doing to this? You are adding some inert gas. You are adding some inert gas. And you know that the concentration means number of moles by volume whole cube by number of moles by volume whole square. Right? Concentration means number of moles per unit volume. We are representing it in the form of molarity. Okay. Now, this piston is not moving. That means, does the number of moles changes on adding inert gas? No. Number of moles before adding inert gas and after adding inert gas will be same. What about volume? What about volume? Is volume changing? Volume is not changing. That means concentrations are remaining same. When the concentration is not changed, then automatically it will be in equilibrium. It will be in equilibrium. So let us take these are gases. What you are taking 2A gives rise to 3B. This is gas and this is also gas. What will you write Kp? Kp is equal to partial pressure of B cube by partial pressure of A square. In this way you write. When you add inert gas, the total pressure is increasing, but does the pressure of A and pressure of B changes? No, pressure of B is not changing, pressure of A is also not changing. When concentration or pressure changes, then that becomes Q. But here they are not changing. If they are not changing, we say that they are still in equilibrium. That means addition of inert gas at constant volume to a reversible reaction which is at equilibrium. If you add inert gas, there will be no change in the equilibrium position. This point you need to remember. This is competitive examination point. There will be no change in the equilibrium position. Okay, understood. So now you are adding inert gas at constant pressure. So let us see at constant pressure. Now you are taking a reversible reaction in a container. Now the piston is not screwed. It can move up, it can move down. Piston can move. What is that? Piston can move up and down. Piston can move. So that is movable piston. But the pressure is constant. So here pressure is constant. P is constant. P is constant does not mean V is constant. Volume is not constant. Pressure is constant. And for example, at a constant pressure of 1 atmosphere. So pressure constant does not mean that volume is constant. Volume can change. Okay. Now there is a reaction, equilibrium reaction. So there is A and B here, both A and B. So A is, for example, 2A gives rise to 3B, which are gases. Okay. Now what you are doing? You are adding inert gas. What you are doing? You are adding inert gas into this. Inert gas. So when you add inert gas, what happens? there will be molecules of inert gas added to it. When you add inert gas, automatically these inert gas molecules along with the molecules of A and B, it pushes the piston up. What does they do? They push the piston up. When they push the piston up, what happens? Volume increases. So on adding inert gas at constant pressure, volume increases. If there is increase in volume, then automatically equilibrium shifts to more volume side. If you see here, how many volumes are there? 2 volumes on the reactant side and 3 volumes on the product side. Okay, now you can also say delta N. Delta N is equal to number of moles of gaseous products minus number of moles of gaseous reactants. That is equal to number of moles of gaseous product is 3. 3 minus 2, that is equal to 1. So delta N is greater than 0. Delta N is positive. When delta N is positive, then on adding inert gas, as the volume increases, the net rate of the reaction, the rate of forward reaction will be greater than the rate of backward reaction. The net rate will be in the forward direction. What is that? The net rate will be in the forward direction, because on adding inert gas, volume is increasing. When volume increases, already we have studied, it will move to more volume side. More volume side is here 3 volumes. That means equilibrium shifts to right. Equilibrium shifts to right. Let us see here. On addition of inert gas at constant pressure, the total volume is increased. Volume is increasing means when you add inert gas, they are pushing the piston, so the piston moves up, the volume is increasing. Okay, so the number of moles per unit volume of each reactant and product is decreased. Okay, hence the equilibrium will shift to side where number of moles are increased. So where are these number of moles more? On the product side, right? Then if you see Kc, for example, Kc is equal to what happens, concentration of B power 3 by concentration of A power 2. Okay, concentration of B power 3 by concentration of A power 2. So what you say, what you write, overall concentration is number of moles per unit volume whole cube by number of moles per unit volume whole square. Okay, so that means here we can say volume is in denominator position. That means concentration whole cube by concentration whole square. Okay, so here what is happening, on adding inert gas, volume increases. When volume increases, concentration decreases. Concentration decreases. So when concentration decreases, automatically it will not be now in equilibrium. It will not be in equilibrium. So here in the numerator, concentration power 3, concentration power 2. So overall concentration decreases. Concentration decreases means Q decreases. Now Q is less than Kc. What is happened? Qc will be less than Kc. Kc is more. Okay, so when Qc is less than Kc, we have studied that what happens? Equilibrium shifts to right, product side. Equilibrium shifts to what? Right side, that is a product side. So why it has to shift to the product side? Because you have disturbed the equilibrium. As you have disturbed the equilibrium, it will behave in such a way to regain its equilibrium. So more forward reaction occurs than backward reaction. So the net rating forward, so equilibrium shifts to product side. So here where the number of moles are increased. If a question is given like this, 3 moles of X gives rise to 2 moles of Y. On adding inert gas to this equilibrium mixture at constant pressure, then what happens to the equilibrium position? Will it move to left or will it move to right side? Here how many volumes are there? 3 volumes. Here 2 volumes. Already we have studied that if you are adding inert gas, volume increases. When volume increases, equilibrium shifts to more volume side. More volume side is which side? Reactant side. So equilibrium shifts to reactant side. What happens? Equilibrium shifts to reactant side. So this is how the question can be asked. Now, if delta n is equal to 0, before also we have spoken. Here what is delta n? Here delta n is equal to number of moles of gaseous products minus number of moles of gaseous reactants, that is equal to 2 minus 3, that is equal to minus 1. So if delta n is less than 0, that means delta n is negative. Which direction? Backward direction. See, backward direction. If delta n is greater than 0, that means if delta n is positive. If it is positive, so at constant pressure we are speaking. So which direction? Forward direction. We have seen already. See, what is that? Here we have seen the reaction is happening in forward direction. Direction is forward. Equilibrium shifts to forward direction. So if delta n is equal to 0, no effect, because the number of moles are same, the volumes are same. If volumes are same, then there will be no effect, whether it is constant volume or whether it is constant pressure. Okay, and at constant volume already we have seen, though you add inert gas, there will be no change in the volume, and there is no change in the volume, automatically there will be no effect on equilibrium position on adding inert gas at constant volume, because volume is not changing. Okay, so that is the effect of inert gas on adding adding inert gas to the equilibrium at constant volume and constant pressure. Okay, so let us go with the next one. What is the effect of pressure? Effect of pressure on the equilibrium position. Sorry, effect of what is this? Catalyst. Catalyst. What is meant by catalyst? First of all, catalyst is a substance that increases the rate of the reaction. It increases the rate of reaction. Catalyst participates in the reaction. What is that? Participates in the reaction. It does not undergo any net change. Does not undergo any net change. That means before the reaction how the catalyst is, and after the reaction also the catalyst will be in the same state. Before the reaction how much catalyst you are taking, something 5 grams or 10 grams. After the reaction also the amount of the catalyst will be same, 5 grams or 10 grams. But it participates in the reaction, it involves in the reaction, and it makes the reaction rate fast. That is, it increases the rate of the reaction. So that is what the catalyst. So what does catalyst do? So for example, there is an equilibrium reaction. A gives rise to B. Okay. So if you don't use catalyst here, For example, it attains equilibrium. It attains equilibrium in something 20 minutes, for example, without catalyst. Without catalyst. But if you use catalyst for the same reaction with the catalyst, by using some whatever it is catalyst, if you use catalyst, it will attain equilibrium in less than 20 minutes. It attains equilibrium in what? In less than 20 minutes. That may be 10 minutes, that may be 5 minutes, that may be 2 minutes, whatever it is. So what is the effect of catalyst here? It makes the equilibrium attain earlier. Catalyst makes the equilibrium attain earlier. That is one thing it does. Then what is the effect of catalyst on equilibrium position? What will be the effect of catalyst on equilibrium position? So it does not affect the equilibrium position. Does not affect the equilibrium position. See, let us see here. Let us take a reaction. So this is what the y-axis and this is what the x-axis. So on y-axis, what is taken? Potential energy. What is taken? Potential energy. On x-axis, what is taken? Reaction mechanism, reaction coordinate. Reaction coordinate. The process of the reaction. That's simple things. So when a graph is drawn, what is found here? This is energy. So here, like this, a graph is obtained like this. Okay. So here reaction has started. So what is this? Reactant. Then what is this? Product. Okay. Reactant, product. How much energy does this reactant has? See, what is this? Energy of the reactant. Energy of reactant. Then what is this? This is what? Here, what is this? This is the energy of the product. What is this? This much amount is energy of the product. Okay. Energy can be written as enthalpy also. Doesn't matter. H also you can write. Now you know that we know that delta H is equal to HP minus HR or EP minus ER. Energy is nothing but enthalpy here. So product energy is greater or reactant energy is greater? Product energy is greater. So as product energy is greater, this will be positive, right? Why it is positive? Why it is positive? Product energy is greater than reactant energy. Reactant energy is small. Product energy is more. So this diagram shows that it is what reaction? Endothermic reaction. Because for which reaction delta H is positive? Endothermic reaction. So this graph shows that this is a endothermic reaction. Endothermic reaction. So now you see this reactant has to gain some energy so that product can be formed. It has to gain how much energy? It is called as ET. What is that called as? ET. ET means threshold energy. Threshold energy. So reactant molecules possess some energy. That energy here it is not sufficient to form product. Reactant molecule must possess some energy to form product. Now here if you see, this reactant molecule is not having sufficient energy to form the product. So how much energy it has to gain? This is reactant energy. When it gains, when it possesses threshold energy, then it can form product. What is this difference of energy called as? This difference of energy is called as EA. What is that called as? EA. What is meant by EA? EA means activation energy. Activation energy. Activation energy. So it is having more activation energy. This much energy it has to gain to form the product. Okay. So what does this catalyst do? What does this catalyst do? When you use catalyst, it will make the reaction to proceed in a different path. See, actually path is this. When you use catalyst, this is without the absence of catalyst. So EA, you write activation energy in the absence of catalyst. In the absence of what? Catalyst. In the absence of catalyst, activation energy is more. Are you finding? Now, when I use catalyst, this reaction is made to follow a different path. This path, let us see this. This is another path. See, this is the path. Okay, understood? This is the path. Now, when you use catalyst, it will follow this path. Now, what is the activation energy? What is the activation energy? You see, only this is the activation energy. So, activation energy P, if I write. What is meant by P here? Presence of catalyst. EAP. What is that? EAP means activation energy in the presence of catalyst. In the presence of a catalyst. So in the presence of catalyst, activation energy is less. So it is easy to form the product. It is easy to gain less energy. In the absence of catalyst, there is a huge difference of energy between reactants and threshold energy. More activation energy is present in the absence of catalyst. When you in the presence of catalyst, catalyst will make the reaction to move in this path where the activation energy is less. So activation energy in the absence of catalyst is more than activation energy in the presence of catalyst. So that is what this catalyst does. This catalyst makes the reaction to move in a different path where its activation energy is less. Where its activation energy is less. Okay. And another more important point is this catalyst will decrease the activation energy same for forward reaction as well as backward reaction. So this point is important. What is that point? Catalyst decreases the activation energy up to the same extent for both forward reaction and backward reaction. So forward reaction, let us take a forward reaction and a backward reaction. So for example, when you use catalyst, it decreases activation energy by 5 kilojoules. For backward reaction also it decreases up to same 5 kilojoules. So as it decreases the activation energy same for both the forward reaction and backward reaction, there will be no effect on the equilibrium position by using catalyst. On using catalyst does not change the equilibrium position. It will not shift to right or it will not shift to left. Why? What is the reason? The reason is that this catalyst for a reversible reaction, it decreases the activation energy up to the same extent for both forward reaction as well as backward reaction. So same decrease, same amount is decreased. When same amount is decreased, then you find no change in the equilibrium position. So what you need to remember is, when you use catalyst for a reversible reaction, it will make the equilibrium position attain earlier. This is what you have seen. Less than 20 minutes. It will make the equilibrium attain earlier, but it will not show any effect on the equilibrium position. So let us see. A catalyst increases the rate of chemical reaction by providing low activation energy path for the reaction. Low activation energy path for the reaction. So let us see the next part. See here, it increases the rate of forward reaction and backward reaction that pass through the same transition state and does not, this point is important, does not affect the equilibrium. It will not at all affect the equilibrium. So catalyst lowers the activation energy for forward and reverse reaction by exactly same amount. This is what the point we have discussed. It lowers the activation energy for forward as well as reverse reaction by exactly the same amount. Same amount of activation energy is decreased for both forward as well as backward reaction. So catalyst does not affect the equilibrium composition. This point is also important. Before asked in the competitive examination, it does not affect the equilibrium composition of reactants and products of the reaction mixture, and it does not appear in the balanced chemical equation or in the equilibrium constant expression. So in the balanced equation, catalyst does not appear. It does not change the equilibrium composition of the reaction mixture, or it will not appear in the equilibrium constant expression. Understood? Okay. So here there are some industrial applications of this Le Chatelier's principle and factors affecting the equilibrium. Factors affecting the equilibrium. So industrial application means by changing the conditions, by changing the factors that determine the equilibrium, you can increase the productivity of some substances. We can increase the productivity of some substances by changing the factors that determine the equilibrium position. So one of that important is production of ammonia. Is that production of ammonia? So N2 plus 3H2 gives rise to what? 2NH3. The forward reaction is exothermic, minus 92 kilojoule. Okay. The forward reaction is exothermic. Forward reaction is exothermic means already we have discussed that at low temperature forward reaction occurs. That means exothermic, no? So the temperature must be low. If the temperature is very low, it is found that the reaction is not happening properly practically. Practical observation if you see. So optimum temperature is used. What is that? 773 Kelvin nearly. And we know that here 1 volume and 3 volumes, and on the product side we have only 2 volumes. That means on increasing pressure, volume decreases. So what we are speaking? We are speaking the conditions which will make the production of ammonia more. We want to produce more ammonia because there are many uses of ammonia. In many preparations we find the usage of this ammonia. So in the preparation of ammonia, to produce more ammonia, what conditions must be used? What conditions must be used? We have to increase the pressure. When you increase the pressure, volume decreases, so that the equilibrium shifts to product side, that is right side. So right side shifting of equilibrium means, right side shifting means more amount of the product is formed from the reactant. That means reactants combine to form more product. So how much is used? 200 atmospheric pressure is used. So increase in the concentration of N2 and H2. When you increase the concentration of N2 and H2, already we have seen that the rate of net rate of forward reaction will be more. When the net rate of forward reaction is more, equilibrium shifts right. If equilibrium shifts right, more amount of ammonia is produced. So on increasing nitrogen and nitrogen, ammonia will be increased more. And for that, we can also use catalyst. When you use catalyst, the rate of reaction increases. Normally we have discussed. So these are the conditions. By applying these conditions, there is increase in the ammonia production is seen. Okay. In the same way, manufacture of SO3 by what process? Contact process. What process? Contact process. The formation of SO3 is accompanied by, you can see reaction 2SO2 plus O2 gives rise to 2SO3. Again, this is also what? Exothermic reaction. 189 kilojoules. Exothermic reaction. Exothermic reaction is favored at, why we have to speak about exothermic reaction? We are discussing about more production of SO3, yield of SO3. How can you increase the yield of SO3? By changing the conditions. What type of conditions you can increase the yield of SO3? As this is exothermic reaction, if you decrease the temperature, the yield of SO3 increases. Why? When you decrease the temperature at low temperature, so at low temperature, according to Le-Chatelier's principle or according to factors affecting equilibria, at low temperature, what happens? Here forward reaction happens. The net rate of forward reaction increases. Equilibrium shifts forward. But practically, if you see at very low temperature, what is found? This reaction is not happening. So they maintain an optimum temperature of 673 to 723 Kelvin. So here, if you see volume, coming to volume, here 2 volumes of SO2, 1 volume of O2 and 2 volumes of SO3. So moving from left to right, volume is decreasing. Volume decreasing means pressure has to increase. So on increasing pressure, again what happens? Forward reaction occurs. The net rate of forward reaction happens. So pressure, we must increase pressure to make the reaction forward, because on increasing pressure, volume decreases. On right side you are finding less volume, on left side 2 plus 1, 3 volumes are there. So more pressure must be applied. So a pressure of 1 to 2 atmosphere at high pressure. See, high pressure is not used, since towers used in the manufacture are corroded. Corroded means they undergo rusting. So optimum pressure is used of about 1 to 2 atmosphere. Anyway, we know that to produce more SO3, we have to increase the concentration of SO2 and O2. On increasing the concentration of reactant, the forward reaction happens. Equilibrium shifts right, so that more amount of SO3 is produced. And even a catalyst is used. And what is that catalyst? Vanadium pentoxide or platinum as a catalyst is used. So what catalyst is used? V2O5 or platinum catalyst is used. When you use the catalyst, automatically rate of forward reaction increases. for this reaction and more amount of SO3 is produced. You are finding at low temperature the reaction rate is too slow, so optimum temperature is used. Optimum temperature is how much? 673 to 723 Kelvin. So two processes are generally asked in the examination. What are those two processes? Manufacture of ammonia by Haber process and manufacture of SO3 by a contact process. How can you increase the yield of ammonia and how can you increase the yield of SO3? What are the conditions they ask in competitive examinations? Okay, right. So that is about the practical or industrial application of Le Chatelier's principle and factors affecting the equilibrium position. Then if you see the overall factors, how they affect the equilibrium position, whatever we have discussed, all the things are tabulated here. It is written, it is made a table, so that looking at this table after going through all this class, looking at this table, this is cumulative situation where the complete chapter is here. What is that? The complete topic of factors affecting the equilibrium position is here. So once or twice you go through this table so that you can solve JEE or NEET question, competitive examination question, with taking less time. Within a short span you can solve the question, right? The summary of this topic what we have studied is here. It is represented in the form of a table. So what is that? Effect of concentration, effect of pressure, effect of temperature, effect addition of catalyst, and everything. Okay, hope so you understood this very well. Let us wind up this session and let us meet in another session with a new topic. Bye. Right, we shall meet again.